Okay, so here we are with chapter 7, dealing with polygons, and the first section that we're going to talk about is triangles. So a triangle is a polygon, it's just a three-sided polygon. So we have just a few last things that we need to talk about with triangles that we haven't talked about before. I know it feels like we've talked about everything that we could possibly talk about with triangles, but we haven't. Okay, so we start off with theorem 50, which says that the sum of the measures of the three angles of a triangle is 180 degrees. And I know you guys already know that because you've been taught that before and we've mentioned it a few times in class. So here it is, officially, theorem 50, you're good to go. Okay, so theorem 51 is a little bit more interesting, which says that the measures of the exterior angle of a triangle is equal to the sum of the measures of the remote interior angles. So you're probably scratching your head right now and saying, wait, didn't we already have a theorem that talked about the remote interior angles and the exterior angle? And didn't it say that the remote exterior angle was greater than either remote interior? And you'd be right. However, this theorem, this one's more exact. So with this theorem, we actually don't need restrictions anymore because we can set up an equation that relates angle 3, angle 4, and angle 1 to each other. So basically what it says is that angle 1 is equal to angle 3 plus angle 4. So let's think about why this might be. Well, if we look at this using theorem 50, angle 2 plus angle 3 plus angle 4 is going to be 180 degrees because all the angles add up to 180. But we also know angle 1 and angle 2 form a linear pair, so we know that they add up to be 180 degrees. So if both of these sides equal 180, we can set both of these expressions equal to each other. And notice that we can cancel out this angle 2 and this angle 2. And then we end up getting angle 1 equal to angle 3 plus angle 4, which is exactly what we had up here. Okay, so that's how you would go about proving theorem 51. Pretty neat. Okay, next. The midline theorem. Okay, so a midline is just a segment that joins the midpoints of two sides of a triangle. So this segment right here, DE, is called the midline, and the midline theorem says that this midline is going to be parallel to the base, or the third side of the triangle, and it's going to measure half of whatever this third side measures. So what we know from this theorem is that DC and DA are congruent, and then CE and EB are congruent, okay? Because that means that D and E are both the midpoints. And so if we know that, then we can say that DE is parallel to AB. And DE measures half of AB. So, for example, if AB is 16, what do you think DE would be? So if this length is 16, what do you think DE should be? Hopefully you guys guessed 8. You go the other way, what if DE is given to you as being 22? What do you think AB is going to be? So if this length is 22, what do you think this length would be? Hopefully you guys guessed 44. And then also, you can take a look at angle CDE. CDE is right here. So this angle right here is given to you as 32 degrees. What do you think the measure of angle A is? And hopefully you guessed 32. Because since those lines are parallel, since these are parallel, those are corresponding angles, so we know that they're congruent. So there's a lot of information, a lot of things that you can do if you know DE, or this segment right here, is the midline. And even if you just know D is a midpoint and E is a midpoint, you can connect them, you can make the midline, you can talk about parallel lines, you can talk about angles being congruent, you can talk about congruent segments here and there, and you know this is half of that. Okay, so a lot to do with midline theorem. Okay. Here's another interesting type of problem that you're going to be asked to solve. It says find the measure of angle E, and they're talking about this little angle here, right? That angle, angle E, not the one that's more than 180 degrees. If they tell you that BE, this ray, bisects angle ABC, and ray CE, this right here, has bisected angle ACB. Okay, so first things first. If we know by definition of bisect that these two angles are going to be congruent, let's just name them X and X. Also, by definition of bisect, these are both going to be the same as well, but they're not necessarily the same as those two angles, so we'll give them a different variable of Y and Y. Okay, so what we do know for triangle ABC, this big triangle, all three angles add up to be 180 degrees. So we can come up with the equation that 2x plus 2y plus 80 equals 180. And so let's simplify this a little bit by moving the 80 to the other side and then dividing everything by 2. We get x plus y equals 50. Okay, that's fantastic. Unfortunately, we have two variables, so that means that we need another equation, right? So what do you think the other equation could be? If you look at triangle BEC, that's another triangle, and we know that all the angles in that triangle should also add up to be 180, right? So let's make that equation. And let's actually call angle E, we'll give it a variable of z. And so x plus y plus z is going to be 180. Okay, well here's the interesting part. We just solved for this, x plus y equals 50. So right here where we see x plus y, we can actually like group this together. Okay, so that quantity right there can be replaced with the 50. So now we get this equation that 50 plus z equals 180. And we can actually solve for z, and z comes out to be 130. And remember, z represented angle E, so we now know angle E measures 130 degrees. Isn't that cool? I like these problems. Okay. So there you have it. You're going to have a couple of those problems that you'll have to do for yourself. So just remember that the first equation, you have the 2x, the 2y, and that angle equals 180. Simplify that down. And then your second equation is the x and the y, and this angle that you're looking for is going to equal 180. And you can substitute what you got here into there and solve for z. Okay, next. Oh, that was it. Awesome. So there you have it. We're done. You guys got off easy. No proofs today. Isn't that sweet? Bye.